Okay, so now what we're doing, we were dealing with, just at the end of the last topic, we were dealing with scatter plots. And we are still going to be talking about scatter plots now. So we had our scatter plots with our explanatory variable and our response variable. And we saw, say, our lines, our dots, sorry. So now what we're going to do is it's similar to a line of best fit, but it's worked out differently. But we are going to now find that linear line or that straight line. So it's like a line of best fit, but it's called the least squares regression line. And why is it called the least squares regression line? Is because of how it's calculated, and I'll show you in a little minute how they work it out. So we think that it's following, we look at the scatter plot and we say, yeah, it's following a linear pattern. So we think it's going in a straight line. So we're going to get this linear regression line. So here is this is the basic formula. So this is the basic formula for a linear regression line, for linear regression. Okay, now we're going to notice a few things, like we have done it last year. So instead of y, obviously our y is our response variable, and we use the letter A for the y-intercept. So in other maths you would have seen it's used at a C, but in general maths we use A, the letter A. We use different letters because ours is not actually a straight line, is it? We are getting a line of best fit, so we have to give it different letters, okay? So we're going to say it's A, but it is a y-intercept when you cross it through. So say if I cross that line up here, that little value there would be your A value. Okay, now the B value, which you can see here in the formula, so the B value there, or up here in B there, that's the slope or the gradient, okay? So you guys would have normally heard it as the M, but now in general maths we call it the B value. And it's still the slope and the gradient. Now also I just want you to pop next to that, they often use, when they're talking about the gradient in this, you'll hear the words on average, okay? When you hear that, they're talking about the slope, okay? So maybe just pop that there because that might help you when you see something, you go, oh yeah, on average, they're talking about the slope. Okay, and the X value is our explanatory variable. Okay, when we go to calculate this line or get this least squares line, we have to remember that we technically can only use this if we have numerical data. So it's sort of like the scatter plot. We said the same thing. You have to have two numerical. We have to assume that it is following a straight line pattern. So if it looks like it's that curve, non-linear, we couldn't technically use this formula, or we would say it wouldn't be appropriate. And then we can also have no outliers. And the reason why we can have no outliers is because of the way they calculate this line. They take into determine the distances, and I'll show you, we'll do that now. Okay, so this is how the calculator will calculate this line. So what is the least squares line? It minimizes the sum of the square of residuals. Now you don't have to know too much. You may get asked to define this least squares line, and that means you need that definition, which is right there, okay? So what is a residual? So what they do is if you see down here on this graph here, we have the least squares line. So here's that red line is the least squares line, and the original dots are there. So what they're doing is they're trying to minimize all those distances between, so they're trying to balance that red line in between all those green distances there. So what that is, those distances are residuals, okay? And they do that, so they square them, and the calculator does it all for us. We don't need to worry, but we do need to understand that's what it's trying to do. It's trying to minimize, have the least amount when you add all those little distances up. So what is a residual? So the residual is that green line I drew, and it's the distance between the actual data value. So here, when I say the y dot value, so say for example, I'm going to do an example here, and I'm going to say that, I'm making this up, that is, I'm going to say that was x at 10, and I'm going to say the y was at 20, okay? I'm making this up. Okay, so, and then I'm going to say down here on that line, that was 15. So when they are working out the residual value, it's the dot value. So what was the R when we were looking, what was the Y value for that first one? I would say, all right, it was 20, yeah? And then it says what was the line? What did it predict on the same X? The line predicted that it was actually 15. So if you did, that one's residual would be 5. Okay, so the residual is the dot value minus the line. Okay, so sometimes you might be given the value in a table of values, but just so you know, we'll do more about it, but the residual is that. Okay, now you can have positive and negative residuals. If your dot is underneath, you're going to have a negative, aren't you? Because it would be under predicting. Yeah? Okay. All right, so we have a couple of ways of finding the least squares regression line. One way is going to be on our calculator, and we would have already seen it when we found our R and R squared values. Our A and B values were there as well. But the other way is if we're not given the data, sometimes we're given summary statistics of the data. So that means I'm being given the mean of the X list and the mean of the Y list, or I've been given the standard deviation of the X list or the Y list. So when we get that type of data, we can find our values. So we need to find our A and B values using this formula. So you can see here, this B. So we're going to find the B, which is what we said was the slope. So you can see they've given that formula there. And what it is we say you're going to do R, so the R value, you know, the Pearson's correlation coefficient, and then you're going to times it by the standard deviation of the Y list, or we should say of the response variable, yeah? And then you divide it by the standard deviation of the explanatory variable, okay? But that's there. So you can use this B value now, and it's all written there for you. Now we also have the A formula. Now you'll notice in the A formula, it has B in there. So you have to find B first if you're trying to find the whole equation. You'll need to know what B is before you can calculate A, because A is. So you could see, if you really wanted to rewrite this formula, so A would equal the mean of the response variable minus B times the mean of the explanatory variable, okay? And that's why we call Y, mean of Y, mean of X. So you'll know you're up for one of these questions when you don't have all the data, but you have been given some stuff, and we'll see it in some exam questions in a minute. Okay, so note, the formula for the slope of the least squares line can be used to find the value of the correlation coefficient R. So, can you see how we have R in here? We've got R in there. So if they tell you what the great slope is and that, you can also use it to find if you don't know what R is. So if I go to the next page, if we have a look here is a formula, yeah, you can use to find R, where you use the B, the slope. So if you want, maybe write that in there, that's the slope. And this is the mean of the explanatory variable oh no, sorry, standard deviation even, sorry. This is standard deviation of the explanatory variable, and this is standard deviation of the response variable. So you could use that to find R as well. All right, so let's go through this question here. Okay, so it says, the height and weight of 11 people have been recorded and the values of the following statistics are determined. So it says use the formula to determine the equation of the least squares line. So what you've got to start doing is going, all right, they want the least squares line. So they want the A plus BX, okay? And it says that enables weight to be predicted. So when I say weight to be predicted, I know at weight must be my RV. And sometimes it's good to then write that is, so say this one, this is the mean of Y, and this is standard deviation of Y. And then height is my explanatory variable, therefore this number is the mean of X, and this is standard deviation of X. Because we need to do that to find our formulas. So let's go, we need to find B first, because B we need for the A. So the formula for B, I'm just copying it off the page before, is this. So I'm going to pop in all the details. 7.44. Now it says to do the equation to 2 decimal places. So at the end when we're writing out our equation and our B value, we'll do 2 decimal places. So I end up getting this to be 0.8673, so on. So if I do 2 decimal places, I'm going to get 87. So I know that is the B value. Okay, I've found the B value. Now if I go to find the A value, the formula, or I'll write it out. Okay, now when you go to find the A value, because you use B in your formula, what I want you to do is, hopefully in your calculator you've already calculated B. So take this answer up here, so go up and highlight it on your calculator and pop it into your calculations for your A. So what I mean by that, I don't want to use the rounded answer. I want to bring that, I'm just going to bring that down from here when I'm typing it in. And then we're going to times 173, the mean of X, 0.3. And I end up with negative 84.8586. But they said, sorry, that's equal. They said to do 2 decimal places, so 84.86. Okay, so that is my A value. Okay, sorry, I've got to move this up a bit. So what they're asking me to do is write the whole equation. We don't want to write Y and we don't want to write X. We want to use the actual variable names. So in the end, I'm going to write, because it was weight to be predicted, weight equals, I'm going to put my A, which is negative 84.86, plus my B, 0.87, and I'm going to times it by my X, which was height. Okay, so just to show you, that was Y, that was A, that was the B, and that was the X. Okay, it says use the following information to find the correlation, the correlation coefficient R. So we know when you have a look here and they've given you some things to do. So if we look at it, and also really important is 3 significant figures. Now, if you don't remember how to do the significant figures, I'll go through with it a little bit briefly today, but there is a link, I can send you a link to the lesson on this, but you should know this by now. Okay, so we're finding the correlation. So here I can see, I'm having a look at this data, and I can see, all right, they've given me the mean of two things. So I'm going to say hours studied and exam score. So I'm going to reckon that's the response variable and that's the explanatory, yeah? We're going to see what you got on the hours you studied. So then what I do is I go, all right, that must be mean of X, and that's mean of Y, and that's standard deviation of X and standard deviation of Y, okay? So they want me to find the correlation coefficient. So I did have that formula, we saw it before, and it said R equaled B times over SY, SX, over SY. That's that formula. So I need to know, I can see the standard deviations of both, but I need this B value. I can read that over here. They've told me it in this line because they told me the equation line. So I've got Y equals A plus BX. All right, so I can see all my information now. So when I go to calculate the R, it's 2.45, because that's what B is, times S of X, which is 1.34, over S of Y, which is 5.42. Okay, the answer I get is 0.6057. When you're doing three significant figures means you start counting as soon as you have a non-zero. So now that's there. So 1, 2, 3. As soon as you've got a non-zero, that's when you start counting. So I count 1, 2, 3. And because once I get that, you do have to look at the fourth one and then you round like normal. So because that is a 7, this goes up to 0.606. Okay, so that is to three significant figures. So once you have a non-zero, you count. So even though there was a 0 after the 6, it was after, so it starts counting. Okay? Okay, so how do you get the least squares line if you've got your calculator? So remember, if you were in, when you were in lists and spreadsheets, so if you remember, you had your EV and your RVs listed. And remember when we went menu statistics and we looked at the R, we looked at the R squared. Well, A and B were also listed there. So you could get your values there. Or if you've done a scatter plot already of data, this is how you get the regression line on the scatter plot. What it does though, so you've drawn your scatter plot, you can get it to produce the line by going menu analyze. The only thing I don't like about this one when you use this is that they always use Y and X. So you've got a kids have a bad habit of writing Y and X in their answer. You never will do that. You will actually be using the variable names. So I like where you go get the A and the B where you find the R and the R squared. You would have had to put them in anyway to get a scatter plot. So let's just go there because then it makes you think more about writing it out. So this one, even though it's the height and weight, they really should have, it should be written that it's weight can be predicted, or W, but they don't do that. And the other thing is it can be small, and I don't know what, I'm just writing what they had on here. If I do 2 decimal places, yeah, so it can be small and hard to read, so it's easier to read the values individually off.